Thank you very much, Eric. So this is going to be in English because I guarantee you your English is substantially better than my Dutch. Well, that's one joke. That worked well. Now I'm going to do something. It's right after lunch. Everybody just had a lovely meal, a couple glasses of wine. So I'm going to start with a joke to a foreign language audience, which is something you should never do. But you can either laugh with me or you can laugh at me. Either one will work. So everybody raise your hands as high as you can. Okay, come on. I know most of you speak English. Okay, now raise them by... Back up. Now raise them by another 3 centimeters. Okay, that is the difference between management by objective and continuous improvement. All right, thank you. So what I want to talk to you today about is operational intelligence, demystified and justified. And to be honest, operational intelligence is another one of those marketing terms. Just like Internet of Things or Manufacturing 4.0, it doesn't really mean much, or it means too much, or it means different things to different people. But it was called this intentionally because I wanted to help everybody understand that there are some aspects of operational intelligence that are quite simple to implement, quite simple to justify from a business perspective. And the way I define operational intelligence is actionable information about manufacturing operations. And if you think back to one of Eric's slides this morning, he had plan, do, check, act. That's from Deming. That's been around since the 1950s. Well-proven methodology. And in that act section of that, he labeled that operational intelligence. And it's about being able to interpret the information you have. It's about being able to analyze the information you have. And it's about being able to take action, to make some changes, to make some improvements. So that's what operational intelligence is. So what I'm going to focus on this afternoon is an MES quality system, a global corporate quality system that we've put in place at one of our food and beverage customers, representing a piece of what operational intelligence is all about. So I'm going to talk just a quick little background on us. We've been operating in the European market for a few years, but many of you may not know about us. So just very briefly, I promise, Eric, I will talk about us. I'm going to talk about the project justification. This particular customer, and I can tell you the customer name, I can't write it down. The customer was Campbell's Pepperidge Farm. It's a corporate quality system that we're putting in all of their soup, beverage, and bakeries. They have a very interesting way of using continuous improvement to cost justify the project. Often it's very challenging to cost justify MES projects. This methodology will hopefully give you some sense of an approach that the business types within your organization will find acceptable. Then I'm going to talk a little bit about the architecture of the application. Eric talked a little bit about digital Darwinism, and part of the customer's need behind this was to have a flexible and an agile system. So I'll just briefly cover the architecture. Then I've got some video clips to show you pieces of the application. If anybody wants to see the application in detail, it's running up on our tabletop display, up where we were served coffee, so you're certainly more than welcome to come and talk to us afterwards. And at the end, I'll give you some real-world savings. This system's been in production at the first plant for a year now, and we have hard data with hard cost savings for that factory. So I'm going to show you that the savings we told the accountants we were going to get, we've actually been able to achieve. So just quickly, who is Callisto Integration? We're a solution provider in the manufacturing operations space. We've been in business for over 25 years now, and in that time we've developed quite literally thousands of MES solutions and controls automation systems. We do about 50-50 in our company. There's about 190 of us spread across 5 offices, and I'm very happy to be able to stand here today and say we just opened our Rotterdam office. That was our 5th office. So that's thanks very much to Eric and the support we've gotten out of the group in Europe. Looking forward to developing that office as we grow further. We operate primarily in those top 3 industries, food, beverage, consumer packaged goods, specialty chemicals. Those probably make up about 90-95% of our business, but we do a certain degree of business in some of the other verticals as well. And we are a Wonderware endorsed systems integrator, and we're also one of the few endorsed systems integrators that have are branded as product partners as well. WEI, which many of you may use to integrate between the MES and your enterprise systems, is actually a Callisto product that's branded and sold by Wonderware, and so is WebSpec, their quality specification product. So let's talk a little bit about one of the major challenges in the food and beverage industry. And this is a challenge that's being faced by most of the large global food and beverage customers, people like Nestle, Campbell's, any of those large multinational companies. they are losing market share to a lot of the smaller, more nimble players. There's been a lot of creativity and innovation in the food market, particularly in packaged food, ready-made meals types products in the past few years. And what's happening is these small, nimble manufacturers are introducing new markets to the product. The big guys are losing market share, and at the same time, these smaller products are consuming more of the consumer's dollars, and what's happening is the large guys are selling their basic products that have a lower margin. So not only are they losing market share, they're losing profit. And obviously from a shareholder's perspective, this is something that they need to address. And we find that there's really two primary responses to this. One is some sort of strategy to preserve market share, and the second is some sort of strategy to grow margins. And they're slightly different strategies. They have some of the same needs, and I'll get into both of those. So the first approach is to do things to preserve market share. And the primary response seems to be to protect what we call brand integrity. So brand integrity is the customer's perception of your brand. When a customer sees a can of Campbell's soup on the grocery store, or they see a loaf of bread from Pepperidge, or they see a box of crackers from Pepperidge, what does that customer think about that product? What do they think about the value of that product? What do they think about their consumer experience eating that product? The large manufacturers, in response to the small manufacturers, have tended to cut costs by cutting ingredient quality. So they take ingredients out. They use less meat, they use lower fat dairy products to try and keep material costs down, but that's caused the quality of the product to drop, and the brand integrity in the customer's eyes has dropped. So in terms of responses to this, there's three tactics we see them using. One is to reformulate their products. They're trying to put some of the good stuff back into their products so that they get better customer acceptance. They're trying to drive consistent quality across all of the regions. One of the things that happens as you let's just call it take quality out of your product. Use simpler, cheaper ingredients. So for example, use less milk fat. There's less margin for error. So the degree of consistency you need in your operations across lines and across plants is much higher than it used to be. So they're trying to force some of that consistency into the factories. And then they're also moving to a center-led quality process. Historically, quality has been very much left up to the individual factories to ensure the quality. As a global company tries to ensure brand integrity, tries to ensure consistent quality, consistent customer experience, regardless of where in the world that product was made, those quality processes are now becoming something that's owned by a corporate quality organization instead of a plant quality organization. The second response is to try and grow their margins. And the way you need to grow margins is by introducing new products to the marketplace. There's a lot of price sensitivity in the food and beverage market. You can't just go and increase prices on your existing products. You need to introduce new products with a higher price point and also with a higher margin. So the primary strategy is for these companies to become more nimble. They need to introduce more products to the marketplace. They need to introduce them more quickly than they have in the past. So what that means is you have to take your product innovation cycle and you have to shrink it. So you go all the way from, in English we call it ideation. It's a goofy marketing term, but it means thinking about something new to do. And I need to get all the way through to the other end of this process, and I need to be able to make it in large quantities at many different factories around the world. The faster I can do that, the sooner I get that product to market, the sooner I'm getting my higher prices, the sooner I'm making increased margins. So we want to help them shorten that down. But this has got some ripple effects. This is moving to what we call a high mix, low volume environment. So what this means is instead of making tomato soup all day, they're now making tomato soup for 2 hours, mushroom soup for 2 hours, chicken broth for 2 hours. There's a lot more changeovers going on. There's a lot more materials in the plant. There's a lot more complexity in the plant. It's a much more dynamic environment than it used to be. And the other piece, and this goes to Eric's point about digital Darwinism, is the large companies are recognizing that the reason they're losing out in the marketplace is because their smaller competitors are more agile. And they're not just agile in terms of the products they bring to market. They're agile in terms of their business processes. They're agile in terms of their business strategies. They're agile in terms of their IT systems that are supporting these processes and these strategies. So Campbell's recognized that in order to implement this global quality system, it needed to be designed from day one to change continuously. They recognized that they needed to change more often as a company. If they're going to invest in new systems, they need to make sure those systems can keep changing as they do. So this all led to something called Project Cornerstone. And the idea behind that is this first project it's the first project in a large-scale, multi-site, corporate-wide MES. Much as I said, operational intelligence means many things to many people. It's a big subject matter. Let's just do something small. It's foundational. Let's build a foundation. Let's address a current business need, a current strategy, one that's got tangible ROI. Let's get that problem solved. And then we'll come back, we'll look at the marketplace, we'll look at where the customer's at, and we'll figure out what's the next piece of operational intelligence that we need to tackle, and we'll build it on top of what we've already done. So this was all around a data collection quality program for the manufacturing network designed to drive two things. One, process optimization. So give the people in the plant, the engineers, the product engineers, the data they need to improve and optimize their processes, and to reduce process variability, which in any conversion type industry, less process variability means less cost. And so the scope for this is we did in-process data collection. So we're collecting information about, for example, oven temperatures, current in dough mixers, things like that, basically process variables that tell us how the process is behaving, as well as collecting product quality data. And the system is being deployed to 14 sites around the world, 5 soup and beverage plants in North America, 5 bakeries in North America, and 4 bakeries in Australia. So justifying this, this is always one of the hard parts about MES, is to explain to the accountants where the cost savings would come from. We had a combination of what I call measurable justification and soft justification. In terms of things we could measure, we could demonstrate that we would save by doing improved and faster continuous improvement projects, and I'll get into that in a second. I'll actually show you some of the numbers. We also knew that we would reduce product variation, which would save cost. Now, we couldn't say how much. So let's say your scrap rate is 7% today. I can't tell you how much better your scrap rate is going to be if you put in an SBC system. I can tell you you will improve it. I just don't know by how much, because you may not have the data to understand what the root cause is and how much of that you're going to be able to save. We also knew that we'd be able to shorten the new product introduction cycle, because as new recipes and new formulations came from product development, they started to make them in the factory. They would collect data about those. They could feed that information back to the product developers quickly in real time. They could make adjustments. And quite literally, when Pepperidge is introducing a new product, every batch will actually be slightly different. They will watch the first batch run in the morning. They will make some adjustments to the formulation, and they will run the second batch with that new formulation. So they can run experiments and finalize products much more quickly than they used to be able to. We also knew that we were going to be able to build on this foundation, that we'd be able to put in a full-blown MES, or MOM, Manufacturing Operations Management Platform, for the future. That wasn't really tangible. There's no way I can put a number on that. So the rule at Campbell's Pepperidge is you need at least 18% internal rate of return. Sorry, I don't know what the Dutch term for that is. It's basically a justification saying that this is like investing money in the bank and getting 18% back every year. And we were able to demonstrate that we were going to get more than that. And primarily how we did this was through more continuous improvement programs. So Campbell's, like many of you, has a Six Sigma program in place. They have Six Sigma green belts and they have Six Sigma black belts. What we did is we went and looked at a typical green belt project. And they have, if I remember that correctly, it's something like 75 green belts across all of their factories. And the typical green belt project saves them, and we have all the historical data to prove this, between $10,000 and $15,000 a year. So we went to the director of their global continuous improvement program and said, if we gave you a data collection system that had all the data in it that you already need, how much more could you do? So again, remember back to Eric's plan, do, check, act. Or if you're a Six Sigma person, define, measure, analyze, improve, control. What we found at Campbell's Pepperidge was that typically for a Greenbelt project, they spend about 4 to 6 weeks collecting and analyzing data. With our system, that dropped radically. In the example I'm going to give you, they spent less than 2 weeks doing the data analysis. So if we can take somewhere between 3 and 4 weeks out of every project, that meant that in a year, their Greenbelt resources were able to do more projects. So what the director said was, okay, I'll put my hand up for this. I will guarantee that every one of my Greenbelt resources will do 1 additional project a year. So that's all this took. not massive change. 75 people doing one extra project a year resulted in 18% return on our investment. What that translated to was somewhere between $750,000 and $1 million US dollars in annual savings. And the way you do this, and I'm an engineer, not an accountant, this seems like lying with numbers, but the accountants accepted it, so it must be right. This is right here, that's our baseline. So we start from whatever the cost base within Campbell's Pepperidge was. Let's say it was, so it's $100 million, whatever it is in a year. So in the first year, we've only got the system deployed at the one plant, so we're going to save $50,000 from the baseline. But in the second year, we're going to do more projects. So we're going to save another $50,000, but we're still allowed to count that first $50,000 because when you do the math, it's a comparison against year zero. So over the lifetime of the system, we generate cumulative savings. If you just did the math here, you're looking at $500,000 saved in plant 1, bunch saved in plant 2, plant 3, plant 4, plant, etc. So when you add it all up over the expected lifetime of the systems, and if I remember correctly, Campbell's used 7 years, we generate millions and millions and millions of dollars in savings, which is why that rate of return is so high. It's a very ingenious way to cost justify MES-type projects. It's much more tangible than a typical justification, and it's also something that people can mentally accept. They can believe that a Greenbelt resource could do one additional project in a year. That doesn't seem that difficult. So let's just briefly talk architecture. It's pure Wonderware. We're using system platform for all of our automatic data collection, and the way this works is any individual characteristic can be either collected automatically or manually. So let's say you're one of their modern plants and you've got thermocouples in all of your oven zones. We can collect all that data. We stream it from the PLC through DI objects. We stream it to Historian, so we have 100% history of what's going on inside the oven. But then we take statistical snapshots. So every 10 minutes, every half hour, we grab min, max, average, standard deviation. We bring it up through the SRO object, the sample recording object. We drop it into the MES database. Or if you're an older factory and you've got RTUs controlling your ovens and we don't have connectivity to them, every half hour the operator can walk around, they can write down the values and they can go and type them in the system. So the system is very configurable. If you have the automation, you do it automatically. If you don't have the automation, you do it manually. On the back end, we've got Wonderware quality. We also use a little bit of operations because we bring the recipes down, including all the process set points, and process set points belong in operations, but most of the work's being done by quality. And then across all of the plants in the world, because remember, they make the same product in lots of different plants, we take all the data and we bring it out, we put it in an enterprise data warehouse, so the product developers are able to take a look at a loaf of bread they made in their Denver plant and a loaf of bread they made in the Richmond plant, and if they're different, they can go back and they can look at the process, they can understand why, they can figure out which of those two plants is doing a better job, and they're able to adopt the best practices from one plant and move it over to another plant. In terms of the data flows, in this particular case, it was tied into their corporate system, so we have a corporate quality system where all the specifications are coming from, flowing over to the MES using that WER product I mentioned. All their process orders are coming from SAP, and then we push everything to the data warehouse. But one of the neat things about the MES offering from Wonderware is you don't need to start out in that integrated fashion. It has all the capabilities to manage orders, to manage quality specifications internally to the Wonderware product. So if you have a smaller site or you want to start with a small proof of concept type project, you don't want to do the enterprise integration, instead of having the connectivity to those external systems, you could have users entering that data into the system directly. So let me do a quick demo here. I'm going to start with order management. So what we've done is we took what we did for Campbell's and Pepperidge and we've tried to develop a relatively standardized out-of-the-box quality solution that we feel would be a good starting point for a lot of our customers, particularly for proof of concept or for a pilot. So you have basic order management capabilities. All the orders that have come in from the ERP system are shown here. Orders that have actually been released to the floor and started are shown down here. We have all of your recipe data. This application has the capability of doing production and consumes. It can post consumption transactions back to your ERP system. It can post production transactions back to your ER system. I'm just going to focus on the quality piece. So this is the piece the operators use to determine what's going on at their individual operation. So this first part of the demo is just showing you how we take advantage of the sample request management functionality that's in the Wonderware quality system to tell operators what they need to do. And so instead of relying on the operators to do the right thing at the right time, we now have the system tell them what to do. So the operator selects the operation in order, and it comes over to the sample screen. And then over here on the left, these are all the open requests, and we use the status to indicate to the operator what they need to do. Black check mark means it's been done. Black X, it was a sample that for some reason they voided. Yellow dot means they can still enter the data, but by the way, they're late. They're not being as proactive as they should be. A green dot means the system's expecting you to enter this data now. So when you select a sample, it shows you the characteristics that are associated with that sample. When you pick a particular characteristic, it'll show you the SPC chart, and you can see where you've had SPC rule violations in the past. So this piece over here with the sample management, where'd my pointer go? There it is. This is how we tell the operators what to do. So they leave that screen up. At every workstation in the bakery, that screen is sitting there, and whenever they see that new row appear with the green dot, they know they need to take them. And I'll show you when we get to the reporting we do at the end, we actually monitor how good a job they are doing of keeping up with the system. Now the second little snippet is showing you actually entering the data. And one of the nice things about electronic data is versus data that you're capturing on paper is we can control the quality of the data. So in a minute, we'll show you an example where we try and enter a number that we know is impossible. The system will actually prevent them from entering that. Whereas when they write it on a piece of paper, it's quite easy for them to make a mistake and enter invalid data. You'll notice that we had the user initials up here. Everything is tracked by individual user. If you have relief work, so let's say normally I'm the bakery operator, but when I get my coffee break, relief worker comes in. If they happen to have to record a sample at that point in time, we want to know that that person did it. The system has got both a virtual keyboard, so if you're using touch screens, you can use a virtual keyboard, or if you have a physical keyboard, you can actually use the physical keyboard. It's all built into the system. So that was a good sample, and you'll see that that check mark, that went from a yellow dot to a check mark, and you see the last point in there. So these late samples, even though they're late, they're still able to actually collect them. So in this one, I believe we're going to show you trying to enter a value that was impossible. So for example, let's say you're measuring pH, and somebody, instead of 14, types 140. You cannot physically have a pH of 140, so the system will catch that, it'll tell them, and it won't actually allow them to record that value. They're going to have to go back and fix it before they can enter it. So we're trying to make sure that they're doing a good job of following the process. We give them the sample request, and we're trying to make sure that they're doing a good job of entering the data. So we've got high quality data. Okay, and then in this next one, you're going to see there's two types of violations. There's a spec limit violation, so we have the upper and lower spec limits in here, but then you can also have an SPC violation, which is when you violate one of your control rules. So the Wonderware quality product has all the different sets of SPC rules in, whether you're using Westinghouse or any other common rule sets. You can pick and choose the rules you want to run. So in this case, we have two values that are out of spec. And when they save the result and it does the chart and it does the analysis, it's going to realize that not only those values are out of spec, they've caused my process to go out of control. It's a common cause variation versus exceptional cause variation. So you'll see that the red indicates the spec violation, and then that red circle over in the SPC indicates I got a rule violation, and you see the red point, and I've gone out of control. So that's just a quick overview, give you some of the ideas of what the Wonderware MES quality product is capable of. And like I said, if you want to see more, you're perfectly welcome to come visit us upstairs. Now let's just talk a little bit about getting data back out, because plan, do, check, act. Act is about interpret and analyze. It's about doing something. It's about making a change. It's making a decision to get better. This is where all that comes out. This is the end of shift report. And really, we were looking for a couple of things. We want to know that the operator is doing a good job of executing their quality processes. We want them to be disciplined about executing their quality processes. So we actually monitor in the system the sample requests that were generated. So in this, when the time frame this report was run, I was expecting 37 results. So that means the system asked for 37 different tests to be done. The operator actually took 31. They missed 4 of them. Don't know why, but I do know they missed them. They didn't void any, and 2 of them are sitting there ready. And that just means the system has asked for them to take them, but they haven't taken them yet. So we can actually collect this data, and from a training perspective, from a process improvement perspective, from comparing the disciplines in one plant to another plant, we're able to analyze how good a job the operators are doing of following their quality processes. So we're actually using the tool to force improvement in the process on the operators because they know they're all being measured by this. And each plant in the network, we collect all of these statistics from every line, we aggregate them all up. That has now become part of the plant's monthly scorecard. So there's a minimum expectation of what percentage of samples you're going to take, and there's an expectation that the plants are going to improve from month to month. So we're using the system to force improvements on the factories. Then down here, we actually record all of the exceptions as well. And historically, what Pepperidge used to do, like a lot of the plants that collect quality data on papers, at the end of every shift, the supervisor would look through all the paper. And for a batch of bread, there's something like 200 different pieces of paper they go through. That was because they had no system to sort of say, yes, you're good, no, you're not good. Well, what we're able to do now, because we've collected the data and we know the operators did a good job, they don't need to look at everything again. They only need to look at the exceptions. So on this report, we print all of the exceptions, and they can look at this and they can say, okay, we violated our height characteristic. I know the rule was one outside of control limit, so that probably means I trended high for a period of time. And the actual value I got was 75. Well, that's right at the top of my spec limit. So as a supervisor, you know, even though it says my process was slightly out of control, it's probably acceptable from a product quality perspective. It's acceptable from a consumer quality perspective. So, okay, I don't have to worry about that. So they can look at the different violations, and they can make a decision as to whether that bread is okay to release or not. And then you see more of these. But then down at the bottom of the report, there are certain things we call key quality characteristics or critical to quality. These are things that if you don't get right, you either have a regulatory problem or you might have a customer acceptance problem. So to make sure that this stuff that was absolutely critical was good, we took statistical averages over the whole run, and we would show all that data to the supervisor. And really the idea behind this was on one piece of paper, instead of 200, to give the supervisor a very good idea of what happened in that shift and give them a high degree of confidence that they're able to sign off on that and release this order. What these guys used to do was they used to ship the product even before the supervisor had reviewed all of the data, because it took so long to review the data. Bread is a fresh dated product. You need to have bread on the trucks within several hours of it coming off of the lines. So because it was fresh dated, they would release it to the supply chain before the supervisors had a chance to review the data and sign off on the data. So the problem with that is if I discover something's wrong, I'm now chasing trucks. I'm chasing breads out of the warehouses. I'm chasing bread out of the retail stores. That's a nightmare. That's expensive. This allows them to not ship bread until they look at this report because it takes them so much less time to do than it used to do. So, the meat, real-world cost savings. In the first project we ran, Six Sigma project that we ran, and interestingly enough, to talk about an agile organization, this was run by a production supervisor. We're talking a guy with a high school education who supervises a shift of bakers. That this Six Sigma project was run by this individual, not an engineer, a product developer, an IT guy, nobody technical. It was, you know, a guy who really understands the factory, really understands the process, ran this experiment. Currently, on this one particular product, they were giving away 5% a year in materials. So that's 5% cost, material cost higher than it should be right away, that they cannot recover from the consumer. And that was really cautioned due to net weight labeling laws. The FDA, which regulates the food and beverage industry in the United States, says if you're going to sell something by net weight, so if I sell a bag of cookies and say the net weight is 200 grams, the average net weight has to be over 200 grams. I'm only allowed 1% of bags that are 5% low. I'm allowed 5% of bags that are 1% low. So there's very strict rules. So what happens is you tend to set your weight set points high. I put a little more dough on the oven belt than I should because I want to make sure I'm heavy enough when I get to the end, but that costs money. So what they're able to determine, and again, remember what I said about Six Sigma projects are typically 4 to 6 weeks. This required no data collection. There was nobody standing at the line with a clipboard taking measurements. This was all data that was in the system. This guy had the charts in the system. He didn't even have to dump the data to Excel and do the analysis. He just went back in the history, looked at every time they'd run this one particular cookie and took a look at the charts. And he was able to demonstrate that this process is very much in control. And he knew he had room to shift the process down. The other neat thing about the system is because we had it at all the different operations in the factory, so we had it at the depositor, we had it at the oven, we had it at final package weight. He needed to shift the weight down at the depositor, but you bake moisture out in the oven. So if I drop weight out of the dough, I need to make sure I don't take too much moisture out in the oven, otherwise I'm going to be light. Well, we had the data that he could demonstrate we had enough room to shift the oven to bake a little less moisture out. So I'm going to take dough out, leave a little more moisture in, I'm going to have good weight products. No experiments were needed, all the data was available, it only took them a couple of weeks to do the sort of run the numbers. And you see what they did here, they just simply dropped one day, quite literally came in and dropped the target weight. And you see, typical thing happened. When you make a correction, you overcorrect slightly. They all panicked the next time they ran it. They jacked the weight back up, and then they realized they were in control, and they jacked it back down. But you see how quickly that step change occurred. Within 2 runs after shifting things, they had the process dialed in. They were producing that product at the new lower target weight. You remember at the beginning, I said this was an 18% rate of return. If every project they did, and every project won't be this good, but if every project they did was as good as this, they would have tripled the expected cost savings. We had a 25% reduction in the amount of material we were giving away, and we had an over 3% reduction in material costs, and there was zero increase in the number of underweight packages we were producing. So this very first Six Sigma project with this new system demonstrated that the savings we had projected were real, and in fact, they actually exceeded what we were expecting to have. And this has given the customer the confidence to roll this out across those 14 plants globally that I was talking about. And I think I'm at 1 minute and 26 seconds over. So I was close. Apologize for running over slightly. Don't have time for questions now. But like I said, myself and 3 of our colleagues are up on a table upstairs. If you want to take a look at the application or ask me any more questions about this project in detail, more than happy to meet with you guys during the break or afterwards. Thanks, Eric.
Thank you, Mike.